Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back to my lecture. So today we are going to talk about the risk and risk behavior. Although we spoke about risk aversion, risk loving, risk neutral, and also in context of insurance, we also spoke about risk premium and how it should be calculated from the utilities perspective. And then we also tried to calculate expected value, expected utility, and the insurance premium or the premium that one needs to pay. So now today we are going to talk about the value of the risky assets, and this is primarily is very important because the way in which the investment is happening and the policy, even certain policies, especially for the monetary policies. So there also from the consumer side we are supposed to understand how choices within the uncertainty where probability of the return is so high and so extreme. So how one should really keep this in mind when we talk about the value for the risky assets, or when we talk about risky assets and how to calculate the value of the risky assets. So first let us understand what is asset. I think more or less all of us we know, especially from our principles of microeconomics class, that asset is something that provides a flow of money or services to its owner. Like if I'm an asset holder of one or two houses, or asset holder of one shop, and if I'm relying on the rent, then of course the rent will be counted, and then asset is basically rent plus the total the asset value if I kind of resell or if I actually continue with that particular asset. So asset definitely provides a flow of certain income or services. Risky asset, that is what it is important. The moment we are adding risky, it means expected value and probability of every event is associated with it. So risky asset therefore is very important to understand. And risky asset is that provides an uncertain flow of money or services to its owner. One can actually take the example of investment on the stock market. Sometimes it is showing very high value or return. Sometimes when market is very slow or low, and then of course expected return or the value that we are getting it from the expected from the risky asset is low or very uncertain. Sometimes you will get high, sometimes it is lost. So that's why average value that needs to be taken into account. So risky asset, that is where probability and uncertainty associated with it. So we will talk about this much more in detail. Risk-free asset is like some fixed deposit or some of the asset that we invest which we know that definite sort of asset, definite kind of return, and that is where we talk about risk-free asset. And here the behavior, like risk aversion behavior of the people who are investing on certain asset which is absolutely free from risk. So that is what option A that we spoke about in our earlier example, say option A and option B. Risky asset is like related to option B, and risk-free asset is option A. So what is risk-free asset here? So risk-free asset that provides a flow of income which is regular and very certain. So that is important. So risk-free asset is uncertain, and risk-free asset is fully certain, like I know what I'm getting it. So now let's move further. Now the next point is of course the return that I have been using it while talking about risk. So what is return? Return is total monetary flow of an asset as a function of its price So the value, basically the valuation of the total asset, and value of any product, it depends on the price, like market price, and then total quantity, that how much I should invest. So if rate of interest becomes low, then I'll borrow more money, or if rate of interest is high, then I'll of course invest more. So that way we try to diversify or try to invest. So so that is the return that we get, and for the return, price is very much important, because that is what the cost of borrowing or rate of return, that's what we calculate or we understand when we talk about rate of interest. So here we are talking about rate of return. So real return is basically the simple or the nominal return on the asset less than the rate of inflation. Is real return is adjusted with the inflation. And then as per our last discussion, one of the earlier discussions that where we already spoke about real income, nominal income, real price, nominal price. Real is basically adjusted with the inflation, nominal is not adjusted with the inflation. So expected return is like return that that an asset should earn on average. That is where probability comes here. The similar kind of calculation that we are supposed to calculate, like when we have the occurrence like x1, x2, x3, x4 and x5, but then that has a probability like head or tail of the coin, or 70% risk associated with the $100 per hour earning, that the example that we had taken. So 7.7 is the probability of getting the highest earning from per hour engagement, or 0 is the outcome but the probability is 0.3 when I lose completely. So those are the probability, but then for expected value calculation, what we do is basically the summation of a product of probability and its associated value or associated return. So that is how even in case of return, we also calculate expected return with its probability and expected every events that we are talking about. So actual return is basically the actual earning or actual return that we get from the actual assets that we hold. So now let's move to the next point, is the trade-off between the risk and return, because that is where one individual, when they are trying to invest somewhere which is risk free or absolutely with risk or risky investment, so their individual always will try to calculate the trade-off between risk and return, and that's how the choice will be made within the uncertainty outcomes which are associated with risky events. Let us assume, like we are going to take the example or the same equation that we already used in our expected utility function for the adverse event and like especially the consumption with the adverse event, and expected utility for the consumption without adverse event. So let's draw on that, and then let's assume that expected return from risky assets, like say I'm investing on the stock market, just an example, or I'm relying on my investment on the gambling or casino, like just assume anything that has a risk, or the example that we had given, like job or the earning which has full of risk or some sort of probability, so that outcome or that job you can actually take as an example, like expected return from risky asset. So we can write that as expected return capital R that we can consider, like capital R, say M. So M is risky asset. So that's how we let us assume. Then expected return from risk-free asset. So here again return is R, capital R, and then expected return from risk-free return assets is like, say we are denoting from with RF. F is like risk-free asset, that is what we are referring here. Therefore risky asset we can write as the condition where RM will be higher than RF. So take a moment here. RM is the expected return from risky assets. So when that expected return is higher than expected return from risk-free assets like RF, then certainly that is the risky asset. So likewise, risk aversion will be, or risk aversion behavior will be, when expected return from risk-free asset is higher than expected return from risky assets. So this is what the conditions that we are talking about. So now we also have to understand investment portfolio in this particular case when we are talking about investment, and this could be investment on the housing, investment on in the stock market, or investment on certain areas in the business, or somewhere where risk will be associated, and that's how investment portfolio needs to be calculated. So now expected return portfolio we can write as return and small p. So here small p is the expected return to the portfolio. So there are three returns that we have introduced here. One is expected return from risky assets, then expected returns from risk-free assets, and then expected returns to portfolio, like where we can combine expected return from risky assets and expected returns from risk-free assets, drawing on the same expected utility functions that we already discussed in our previous class. So we'll bring the same. So here we are introducing B. B is the probability of expected return from the risky affair plus 1 by B. As we know, the total probability is 1, and if B is the probability of the return or probability of the return from the investment on the risky assets, and then 1 minus B will be probability of expected return from the investment on the risk-free assets. So here 1 minus B are F. So this is the expected value of the expected return to portfolio that we are going to talk about, right? So this is what we got it from expected utility function. So this we can give as say equation 1. So now moving further, so how to calculate risk or measure risky portfolio? So this is what we want to highlight here. So if you recollect that we have shown the risk amount, how to calculate risk amount, and then risk amount was the difference between the utility curve and then the straight line that we had drawn. It's like actual utility, the difference between actual utility and then utility that we are getting it from gamble or from lottery or from say stock investment on the stock market, the kind of utility that we are getting it. So that particular difference is that risk that we had drawn, and based on that risk we calculated the premium. And here that particular risk in case of portfolio from the risky assets, how we need to calculate. And here the one of the measures that we are trying to do is the standard deviations. So what is standard deviation? I'm sure all of you know. So here the conditions that we are trying to put it, like here, like sigma p, which is standard deviation for investment portfolio, which is nothing, it is basically probability, like probability associated with the standard deviation of risky return of the risk from the risky assets. Like M is stands for the risky assets. So as we know, just for your reference, that standard deviation is nothing, is basically the square root of the say 1 by capital N summation of xi, it could be it is like capital XY, it could be, and then mu square. So it is mu is a mean, and then capital N is the total number of population, X is the number of observations, and this is what we actually calculate standard deviation. So this is the formula here. So now say the standard deviation, like measuring risky portfolio, we measure with the standard deviations, and this is how we calculate here. So now what is the investor's choice? So we can write from equation 1, we can write capital R P equals to B R M plus R F minus B R F. So this is how we calculated, right? So we just from equation, it's like from equation 1, so we can give equation 1a. So from here we can rearrange. So rearranging from equation 1 is like RF plus B RM minus RF here, and then we have the from, so you can give equation 3, and so from equation 2, like from measuring risky portfolio that we know, that's from the standard deviations formula that we already know that this is what, and then from here we get the value of B, which is nothing, is the ratio of the standard deviation between portfolio and risky standard deviation of risky rate of return from the risky assets. So if we put the value of B in equation 3, then we get, so putting the value of P into equation 3, we get RP, which is portfolio, RF plus RF. So now we can also write same thing, we can write in a different way just to show you the relationship, the functional relationship between the factors that are associated with the risky assets or risk-free assets. So it is, one can actually write this as Rm minus Rf divided by so this could be, say, equation 4. So equation 4 is clearly indicating, like here, the relationship that we are trying to establish here. If standard deviation of portfolio increases, then return investment return on the portfolio will be also increasing, right? Why? Because RF, like rate of return from the risk-free assets, which is always known, and that's how the risk aversion assumptions. So it is constant. So it is known, it is constant, and we also know the difference between the expected rate of return from risky assets and rate of expected return of from risk-free. So all the component indicators like RF, RM, RF, and then standard deviation of M, all are known. So if all these are known, rate of return on the investment portfolio will be depending on the standard deviations of the portfolio. So these are they are positively related. So now, so here if you closely observe, so particularly this particular the section from here is basically nothing, is basically the budget line between rate of return, expected rate of return from the investment portfolio, and then standard deviation. So that is what the functional relationship that we are talking about. So if we draw this, so in the budget point of view, so if graphically if we plot this on the vertical axis, it is rate of return on the investment portfolio. On the investment portfolio, on the horizontal axis is the standard deviations of the from the investment portfolio. So the budget line that we are drawing here, so from equation 4, RF is the intercept here, because expected rate of return from the risk free assets, which is known, which will be the reference point, and that is the intercept point, and then it increases as your risk is increasing, you are taking the risk, and then your risky expected return on the risky investment portfolio also will increasing. So that is what we are trying to calculate. So it is basically expected return to the portfolio. So that is actually positively related with the standard deviation. So it is directly proportionate with the risk. So obviously this is the budget line that we are talking about, because it has that feature. So but in this particular case, budget line is the upward straight line, unlike our traditional budget line, which is downward sloping straight line, which is linear in case of consumer theory. That's why if you remember in our first lecture of this particular week, when we began this choice and technique, we are saying that the features and indicators, and when we talk about uncertainty, the economic outcome that we are actually showing and then talking, that is actually challenging to the traditional choice and uncertainty discussions, especially in the microeconomics point of view, especially in the consumer theories point of view. So this is what the budget line, straight line, which is upward straight line, which is absolutely opposite, quite opposite than the what we understand from the consumer choice theory in our traditional microeconomic theories. So now when we talk about the choice, so this is how the trade-off will take place. So trade-off between risk and return, but then here trade-off between expected rate of return on the investment portfolio, and then expected and then the standard deviation. So standard deviation is basically the risk component, and then expected return on the investment portfolio is basically the return component. So here is the trade-off. So now when we are talking about risk, so we are not talking about risk aversion now, and we know that in case of risk aversion, utility curve, marginal utility curve is actually concave, right? Utility curve is concave and upward sloping. But then in case of risk loving person, and then since we are talking about risky asset, so here we are actually bringing risk loving behavior, and then here utility curve or marginal utility, the total utility curve will follow the increasing returns to the increasing returns features of the marginal utility, and therefore utility curve will be convex and upward sloping, so it is increasing. So here say one utility, so here another one utility, here the other utility. So here we get the indifference maps curve, like utility maps here, so like U1, U2 and U3. So here we can see there is a tangent point with the U2 at point say r, small r, and then along with the small r we get equilibrium standard deviation, like how much risk can be taken. So that particular measure can be easily measured through the standard deviations, and corresponding to this risk, then we get optimum level of return from the investment portfolio. So this is how choice that are taking place, and then trade off between risk and return that are taking place. And I hope this is clear in this particular context, like especially in context of trade off between risk and return. This is very, very important calculations even for you when you try to invest on the on certain sector which is which has full of risk, and there you have to calculate return and the risk, and then how you really need to calculate, and that one can actually calculate from the utility. So this is what we try to discuss. And also in the public policies point of view, this is very important, that how to calculate utility when there is a choice is involved between risk and return, and then there is a trade-off. So I stop here, and I have used again these 3 books for this particular lecture. So for further details and for further more examples to understand this concept, like risk and return, and then how the choices are being made among all the indifference curves, and also between various investors. So you can go ahead with this select from the selected chapters of this particular book. So I stop here, and thank you very much for your attentions, and I'll see you in my next lecture.